Okay, good morning to all the remote centers and good morning to all the participants and the coordinators of the remote centers. And this session, I'm going to tell about some research problems and some neural network toolbox, what very initial commands of neural network toolbox that you can use for fitting tool or clustering tool or the pattern recognition tool, right? So let us take the first example, that is your clustering of atmospheric condition of different floors of building using ART1 algorithm. Depending on the atmospheric conditions, we can find out the energy that has been consumed in all the floors of the building. So that is the first problem. Let us take in the clustering tool, that is a clustering of atmospheric conditions of different floors of building using ART1 algorithm. Now, so data set, right? You can use the ART1 or you can use the other also. First of all, let me show you that how to fitting tool can be used for this problem. So this is my data set, that is your building data set, right? This is your building data set I am writing, right? And there are in the building database, there are two fields, two variables. One is your building inputs, another is your building targets. Whenever we will do the neural network problem, these two options, in case of the supervised learning, these two fields should be there. One is your inputs, another is your target. So in our case, the building input is your some 14 into 4208 matrix. That means there are 14 variables and 4208 are the rows. That means 4208 are the values of the houses. These are the values, these are 4208 are the number of houses, and each and every house there are 14 variables which we have taken in the data set. Now what are the variables? First variables are the 1 to 10, these are the day of week, right? These are the days of week plus time of day, that means 7 days, and the time of day means that is your hour, minute and second, right? So these are the 10 variables. First of all, there are 10 variables. There are coded day of the week, that means 7 days of the week, plus time of day. Time of day means there are 3 divisions, hour, minute and second. After that, there are temperature, that is your one variable, humidity another variable, solar strength another variable, and wind is your another variable. There are 14 variables we have taken in the data set, right? So the target in inputs, we have the 14 into 4208. In the target, we have given the energy usage, and we have given the 3 outputs. Now what are the outputs and the targets, that we will see. Now simple program is that building data set, it will come to the, when you load the building data set, it will come to x and t. X, it will take the values of inputs, and t, it will values the targets. After that, we are using the neural network toolbox command, that is your fitnet, right? After that, we are giving the fitnet. 10 is the hidden neurons, right? How many hidden neurons, that is your own wish, that what are the number of neurons you want to take. After that, after fitnet, it is coming to, you are training the network, right? First of all, we have the network we have fixed up, that our network will have the input neurons 14, hidden neurons 10, and the output layer will have the output neurons are 3, right? In building database, there are 3 outputs only. It has been fixed, right? Now this is your inbuilt database in neural network toolbox. I will show you in MATLAB also, and after that we will train all these network, this net x comma t. This net means that what are the hidden neurons you are taking, and x comma t is your input x and the target t. After that, you can view the network, and after that you can output or the plot the network or output the network, right? So this you can do it. So let us see that in MATLAB what it can be. So we can just start the MATLAB. So here for the fitting tool we have NF tool. For the fitting tool we use the NF tool, right? If it may not be so much visible to in your presentation or in your PPT, whatever I am showing, so you can just note down that what are the toolboxes I am telling. So for the fitting purposes we use the NF tool, for the clustering purposes we use the NC tool, and for the pattern recognition purposes we use the NPR tool. Right, there are 3-4 tools are there. First of all we do the NF tool. When we'll say the NF tool, this toolbox or the neural network fitting toolbox, it will open. Right, now it will ask, as I have told you, first of all we have to input the database. Right, when we'll say that this is your toolbox, but it is an that is a it is inbuilt toolbox is there. Now when we'll say next, now here there are two buttons are there. One is your inputs, first one blue button is your inputs, and the orange button or the red button, it is telling the targets. Now you have to give the inputs and the targets. Now when you will have your own database, right, where you can use the database, that time you have to select this and you have to just choose that what is the database, where is the database is present. But since we are taking the inbuilt database, so let us take the example data set. So we have taken the load example data set. So we will take the load example data set. So these are the data set are available for the fitting problem. You can take house pricing, you can take the body fat calculation, you can take the building energy calculation, or some chemical purpose or some engine problem. So we have taken the building energy problem that I have told you about the building energy problem. So in building energy problem, it is showing that what are the inputs are available. Similarly, when you will click on the body fat, then you will see that these are the inputs. 11 inputs are there: age, weight, height, neck, and all these things. But when you will do yourself, then these database you have to fill it up, or you have to take it from the Google or some other database. For example, for the IDs database, there is a database available there. For the mammograms, there are some available there. For some symptoms in urine, that is the some available data is there. Some cancerous check for the any cancer detection, their database is there. So different database, IRIS database is there for the IRIS purposes. So different databases are available for these different applications. So here I am showing you the inbuilt database, which will be easier for you to understand for the first time. So let us take the building energy database. When we'll say import, these databases you can do yourself also. These databases you can search it, that is CSV format. It must be in your MATLAB or the bin directory, and from this you can just load into your own directory, and you can use at your own as your own database also. Not only like this, that only the inbuilt load inbuilt data set only you can import from your own folder or own database. Now we will say that is your import. When we will say import, automatically the toolbox will take in the inputs, toolbox will take building inputs, and the targets, it will take the building targets. Right, automatically it will be considered. So after that you can change. Here it is showing that in building targets these many the input are there, and in building inputs these many metrics are there, 14 into 4208. And after that if you say next, then automatically it will check you that how many neurons you want to add. So here it is asking the number of hidden neurons. Now it is giving default is your 20. You can give 10, 15, and you can just give trial and error method, and you can just check it that in which neuron, number of neurons, hidden neurons. You should not give so many, hidden neurons. That should be optimal value, and with which value, you can get the MSE and your regression value is less. Now here, whenever we have given the 10, you will see this is your neural network. This is a 14 input it is showing, and here it is showing that is hidden neuron, that is 10, and the output layer it is showing that 3 neurons, and finally the outputs are 3. Right. So when you will say next, then it will ask you to train the network. Right. First of all, as I have told you in the PPT also, first of all we have to set the neurons, hidden neurons, that we have set it with the help of the some that is your this set fitnet. We have used the fitnet tool for using this network. So sorry. So we have used the fitnet tool to fix up the hidden neurons. Similarly, here also we are doing with the help of these visual tools that we have fixed up the number of neurons. Now we have to give the training model. In case of training, there is a possibility that you can 70% will be taken for your training purposes, 15% will be taken for your validation purposes, and another 15% will be taken for the testing purposes. So therefore, this is the samples it is giving. You can change also. It is not like this that 70% only you have to take. You can take 60% or 25%, 15%, like this you can change it. So here it has been taken as your 70%, 15% and 15%. Similarly, the number of samples 4028 samples has been divided into this. That is for training we will be using the 2946 samples. For the validation we will be using the 631 samples, and for testing purposes we will use the 631 samples. Now if we say the train, I have trained the network. Now it will be automatically, it will do the iterations what we have learned earlier in all the networks, whatever it may be, the ART1, it may be the back propagation, it may be the Hopfield network, it may be the Mac-Pitts model network, it may be the SOM method, whatever method you want to do, there will be the epochs or the number of iterations. So it is doing then automatically, it is doing the number of iterations, and after it will be it will do all the iterations, then it will give us that what is the data of the MSE and all. Now you can see that after iterations, how many iterations that I will show you, it is showing that MSE is equal to this and regression value is this, right? So if you want to change, if it is same as your it is your expectation of this MSE, then it is okay, then you don't have to retrain again. But if you want that no, now my MSE again it should be minimized, then it should be retrain and retrain, so that you can get the your whatever you have taken the limit of your MSE that you can get. Now in case of when we have trained it, now we have got 36 iterations. That means here we have got the 36 iterations. After that we have got some plots also. For example, performance test. So if we click on the performance, for the performance we use the plot perform. If you don't want to use the neural network toolbox, you just want to write the programming in MATLAB. So I have told you that for the fitnet we use the fitnet command, for the train we have used the train command, and for the performance put up के लिए हम लोग use करते हैं plot perform, PLOTPERFORM. So plot perform command is used to plot the performance. What is the performance? Our performance is the mean squared error, that is your MSE. MSER is the mean square error. So after 36 epochs, it is showing that our MSE is somewhat as your something into 10 to the power minus 3. Now if you want to retrain it again, so let us do the retrain again. Now it will retrain again after after some iterations, again we can get the some values. Now let us see that after retraining any MSE value will be reduced or not. Now it is doing, and in the case of the iterations, after iterations you can see the what are the training state, what is the regression values, and all these things, that also you can check it. in the actually training state, it gives the how the gradient values varies and all these things that I will show you in the graph. So first of all, it is doing the iterations. So now it has been increased. First of all, we had first time we had trained, it was doing the only the 36 iteration. Now it has been increased. It has been increased up to 52 iterations. Now let us see that when we'll see the 52 iterations, that you see 52 iterations, that means definitely when you will increase the iterations, there is a chance that you can get the more accuracy. Of course, it will be into terms of 10 to the power -3 or -4. The term will not be so much varies, but you may get, for example, first time you have got 0.002. Now you can get 0.0018. After that you can get 0.00175. Like this, very smaller value or the minor variation you can get after retrain, but you have to retrain till you get the minimum value of the MSE. Right now, whenever we will see the performance, again we can get the this type of value, that at which this round value it is showing that best validation performance. It is showing in the above that at epoch 46, that means this is your 46 epoch. I suppose that with the mouse I am able to show you this is your epoch number 46. At 46 it is giving the best validation performance. That means it is giving the minimum MSE. Now if you do retrain and MSE will be reduced. Now this is your performance. After that you can say the what is the training state. That means what are the validations. That means 52 validations are there. It is showing that validation checks, right, 0 to 52. What are the values it has come into the validation, or it has given the gradient. This is your gradient at epoch 52. What is the gradient or how it is descending? We have tried that in backpropagation network with the gradient descent method, steep gradient descent. So here from the graph it is showing that gradient was this much, and after that, after 52 epoch, the gradient has been reduced to this much. So this type of plot you can see in case of this retraining. And when you will say next, right, you can say train again, or you can say adjust network size. Adjust network size means that you can give the more number of hidden neurons or the less number of hidden neurons, and you can check it that how the performances can be changed, right? And after that you can take the import larger data set. That means you can import the many other data set also at this point. And when you will say next, now it is showing that there are 4 outputs. One is your net, not output, these are the variables. One is your error, one is your output, another is your info, another is your net. Now you can just click on the save results, so it will save the result in terms of matrix form. And after that, that matrix form you can take on your thesis note, and you can just plot it that these are the error values you have got, right? In matrix form it will give. And there is another advantage is that you can generate the M file also directly. Till now we have done that whatever Toolbox is said, or the visually we have done with the help of the GUI, so that it will be easier to understand first that how it works. So first of all we have come to know that one step by step what are the process or what are the steps to come out as the performance or the MSE. Now if you say generate M file, then you will get the whole M program or the MATLAB program that will come in front of you. That you can, after getting the M file, you can copy it, you can modify it, you can change it, you can manipulate it, you can, play with that program. Whatever you want to do, you can give the different, training function and all. Now, I just show you that what they have done here. They have done that what we have used into the GUI, that only they have done. They have found out some function, right? They have taken that num hidden neurons. Hidden neurons we have taken as 10, so that's why it is taken as your 10 only. Now it is giving the new fit. That means this is your the algorithm, that fit algorithm, that is you are fitting those values. So this is giving the input what are the number of inputs, what are the number of targets, and what are the, you know, the hidden neurons, how many number of hidden neurons. After that, it is showing that this is your training ratio, that is, I have told you 70%, 10%, 15% and 15%. So it is showing that training ratio will be that 70 by 100, validation ratio will be 15 by 100, and testing ratio also 15 by 100. Here when you have got this M value, M program, then automatically you can change the validation and all these ratios, and then you can check it that how the performance varies with the help of this, right? After that, they have done the train, right? As we have written in the PPT also, I have shown you the train is your one command, that is to train the network. So in train, we have to give the net. This net is coming from here, right? Whatever neural network you have put, inputs, outputs, and the, you know, the number of hidden neurons, that then this net will take, and then again the inputs and the outputs it will take. So the output will come to the two variables, one is your net and the TR. And with this help of this value net, again we have to just simulate the network and we can find out the output. So after that, I have told you that to plot the performance, to plot the, you know, the training state, on to plot the fit diagram, so we can use the plot PRF or PERFORM, total plot perform, या तो plot fit हम लोग use कर सकते हैं for the fitting tool, how to show that how it has been fitted. And another program is your, that is your plot regression, right? So these are the three programs that have been generated by the GUI only. After that, when you will get the basic module, after that you can change it and you can do in your as your requirement. So again, let us go to the PowerPoint again. So this is your whatever where I have left you here in this point. So in the building energy detection, I have told you that how it can be done, very simple program. It can be done with the help of the neural network toolbox, how the GUI can be used, or how the data set we can write our own program also. Now next program, let us see. That is your calculation of error of AND gate logic in backpropagation learning. AND gate logic, right? AND gate we have done already. That is your what we are doing. That is we are doing the feed forward network, and also we are doing the backpropagation learning. Here I have given that first of all, that is your feed forward network. So what is the input? Input is your X, that is your 1 1, as I have in the matrix form, that is 0 0 0 1 1 0 and 1 1. These are my inputs, and this is my target, that is your 1 0 0 0. These four are my targets. Now just you can write feed forward net. Now this feed forward net is a command to just find out the feed forward network, right? But in case of MATLAB 10 or MATLAB 7, if you have the MATLAB 10 or MATLAB 7, this feed forward net command will not work. For that time, in that version, we used to use the new FF. We used to use the new FF. NEW FF, right? NEW and FF. So this we used to use, but here we are using the feed forward net, because if we use the MATLAB 12 version or the 13 version, then we can use 14 version, we can use the feed forward net. After that, we are using the train, as I have told you, after that view net, right? This is your feed forward network. After that, that next portion is a backpropagation learning. I am telling you about the backpropagation learning of the one input, that is your 1 and 1, right? 1 and 1, the backpropagation learning. What is the process? After that, you can, you know, for all the inputs, you can do it one by one. Just to say that in backpropagation, just to remember that in backpropagation learning, what we had done, there were two layers. One connection is from input to hidden layer, another connection was from hidden layer to the output layer. That means the weights are connected from the input to the hidden layer and also from the hidden layer to the output layer. There are two number of weights, as you must be remembering. We had taken for the when we had done the algorithm, that time we have taken V and W. Now in this case we are taking Wij and wjk. wij for the hidden neurons, input to the hidden layer, and the weights from the input layer to the hidden layer, and wjk is your for the hidden layer to the output layer. So there are two weights we have taken. There's a two random function, that is your two random 2 comma 2 and the random 2 comma 1. That means why it is 2 comma 1, because in case of first one, that is your wij, we are taking the random function as your ra and b 2 comma 2. That means there were two inputs, and in hidden layer outputs also there are two. This is 2 is your hidden layer outputs, right? So that's why we are giving 2 comma 2. But in case of wjk, that means for your hidden layer and the output layer wjk, we are giving the random function as your 2 comma 1. That means hidden layer output is your 2. That means output, in the output layer the input will be 2 and the output will be only 1. That's why we are taking the weights is equal to 2 random function 2 comma 1. Now there are some basic commands, that is your x level and number of iteration, title, MSE convergence graph, and is your y level, mean square error. These are the very basic. Now for the 1 1, that is your input 1 1, what is our target? Target is equal to d is equal to 1. That we are taking as a target. That is your d is equal to 1. And L equal to 1 we are taking for the iterations, that how many iterations we want to do. That we had done that con equal to 1. Here we are writing that is your L is equal to 1. So first of all we are taking that MSE equal to 2. That we have taken, that is MSE equal to 2, and we are giving the condition that till MSE we get greater than 0.01. That means our limit is your when we will get equal to 0.01 or less than 0.01, then we will come out of the loop. Now we are giving while MSE is greater than 0.01, then you do the hidden layer calculations. I will give you all the PowerPoint, so don't worry. You just try to listen and try to understand. After that I will just mail to all the coordinators and you all will get all these commands, right? So first of all we had initialized the weights. After that we had given the target, because finally we are giving that x equal to 1 1. You can give it into the loop also, for these values to these values. So after that we are giving that MSE should be greater than equals to 0.01, then the hidden layer output calculation it will be done. Now hidden layer output calculation, because x is your input and wij is your the output. So when x and wij we are doing the multiplication, that we are giving the net, and after that we are finding the sigmoidal function 1 by 1 plus e to the power minus net j. So that will be the sigmoidal function. After that we are finding the output layer calculation just like this, and the MSE, this is the formula. MSE will be 0.5 is your learning rate and d minus fk whole square. That will be our the MSE formula, as I have told you, delta learning formula, that is t minus output, t minus o whole square, right? Half is your 0.5. So after doing the MSE, after calculating the MSE, we have to calculate the delta, because delta W and delta the weight the weight updation for the hidden layer purpose and weight updation for the output layer. So we are taking that delta at the kth layer. Kth layer means this will be the output layer, and delta is your jth layer. That will be your hidden layer. So this is your delta k. Delta k I am writing d minus fk into fk 1 minus fk. This is the formula we have done already. This is your delta k and this is your delta h. That means delta k is your basically in the output layer. Delta h is basically in the hidden layer. And similarly we can do the wij new. Wij new will be equal to wij old, that is your wij previous one wij plus the delta h into 0.5 into x, alpha into delta h into x, or whatever formula we had got. So after that wjk also we have found out, and this will go on till this MSE will be less than equal to 0.01. So after that, when we'll get the MSE is less than 0.01, it will come out and it will show you the plot MSE, right? It will show you the plot MSE, and finally you will get the MSE output. So this is only for one input. I will just show you that in MATLAB also I have just stored it. I'll just show you that what is the output. Let me open the file. So this same thing I have just copied it into the MATLAB, the window, and this is the same thing I have done. Just copy paste. I have done whatever I have written there, only I have just copied it. And when we will say we will run this, then we will get some, this is your graph of the MSE that I have given at the last, that your plot MSE for 1 1 only. After that again it should be done for 1 0, again it should be done for 0 1, again it should be done for 0 0, and finally the MSE, what will be the MSE that you have to put. So this is your MSE plot. That is, you can just see that how it is moving to the negative direction. That means MSE is reducing. Similarly, because we have given the neural network train and the new FF or the feed forward FF, so we can get the neural network view also. Here, here also we have got this iterations. So there are 3 iterations they have done in the program. After the 3 iterations only we have got the achievement. So only 3 iterations they have done. Here also you can see the performance, that how validation performance at epoch 3. That means at epoch 3 only we have got the best validation. So this, they are giving the training, validation and testing graphs and all these things that you can see. So this is your just another example of the that is your AND operations with the help of the backpropagation learning. So the third problem that we will show you, that is your an implementation of extraction method of handwritten digit recognition tested on the MNIST database. This MNIST database, it is available in the net, Google net. So you can just download it, you can just use it, right, directly. So handwritten digit recognition, this is only one journal paper that I have told you to search one journal paper that we will discuss after tea break. So this is your extraction method of handwritten digit recognition, and I am just showing you that what we have done. So in the Word file, just I will show you the steps what we have done. Let me just increase the the view point so that you can just check it. So what we have done, this is our MATLAB code with stepwise output. So this has been done by my students only. So first of all, what we have done, we have opened the file, that is your another open. I'll just increase again. So I suppose this is visible. So what we have done, first of all, we have opened the file. Whatever file we have, it will be this file actually, the MNIST database. It is your this format .ix3 and ubyte format. So directly we have called it, and it will be when we'll open the file, automatically it can be read. Right. So this is your file, and we have opened the file here, and it has been stored into the train img file. After that, we have read the file, that is your fread, right? Fread the file, and train img is that database what we have created, and this we have read the file, and after that we have given that how many number of rows are there, how many number of columns are there, how many number of images are there, so that we have taken care of. After that we are doing this, these are some values, and final, actually I'll just want to tell you that what basic problem what we have done. So this we have taken care of only one image, that is your 5, the image of 5. That has been, this image has been taken care of from the MNIST database only. After that, what we have done the dilation. So there are 4 direction, and we have done the dilation in the 4 direction. Dilation means expanding, right? You are expanding the area. So this is your east dilation. This is the program we have done, and finally we have got the output as this is your east dilation. That means from the east side, that is your, this is your north, this is your south, this is your east, this is your west. So from the east side again we have expanded, right? The gray value, that is white background, we have expanded. Now similarly we have done the south dilation. So you can see that in the south dilation, that is your, in the below side of the diagram, that we have expanded. So this is your south dilation, and this is your north dilation. These are the some portion we have done for creating the, finally to select the image and the characteristic zone, some characteristic zone very accurately. So this is our north dilation as we have seen, and something we have done for the west dilation also. So finally we have got it. So that is your west dilation. So these are the 4 dilation process we have done to expand, so that the image can be, you know, we are expanding so that the image can be recognized very accurately in the next portion. Somewhere we have done after the dilation, because when till we do not expand it, so we cannot find out the characteristics zone. So we have found out some characteristic zones, as a west characteristic zone, east characteristic zone, like this. I will not go into details. I am just telling you that how we have done. So this way we have carried out some characteristic zone also here, and after that finally when we have recognized this with the help of the thinning process and all, we have recognized this 5 character. And after that we have, you know, this type of, after doing this is just up to this, it is just image processing. That first of all image is there, we have done the dilation, we have found out the characteristic zone, and finally we have done the thinning. And after the thinning we are getting the only one line, you know, to recognize it has been thinned, or it has been it is giving us the skeletal values of this 5. And finally what we have done, that we have passed through the, you know, the neural network, all the images, whatever images we will get, just like this, all the images. For example, there are near about 10,554 images are there in MNIST database. So all the images it is not possible. So you can take, you know, for the thesis purposes you can do it 50 images, or the, you know, 60 images. Like this you have to do all the images you have to do, and you have to all the different images. This 5 image I am showing you, that is the only one type of 5. Like this you have the 500 types of 5s. That means 5, somebody has written, you know, in the straight way, somebody has written in the tilted way. Like this you have to pass through all these type of 5s in this process, and you will find out the actual skeletal value of 5. After that you have to store in the database. Then all these values again you have to do the learning procedure, so that your neural network learn all the network, that how to recognize your character, so, or digit. So finally when you will give any validation digit or for testing digit through the network, and finally it will, because input you will be giving only for the training purposes, and finally it will designate that this is the digit, or this is the character, whatever you want to, you know, the alphabet, whatever you are giving, or the number you are giving, that is your own wish. So this type of work you can do. For example, what you can do, this is the network with your, you know, numbers. So this thing you can, you know, just change at your place, or you can give some work to your student for all this process only. With this process only, the dilation, characteristic zone, and the neural network, this algorithm only, but it can be extended to the characters. It may be extended to the Punjabi characters, it may be extended to the Tamil characters, it may be extended to the, you know, Hindi characters. So this type of algorithm, using this algorithm you can just, you know, do your research work in various fields. So my aim is to show you that this type of problems you can do with the help of the neural network. So another one I'll just show you, that is your cancer data using the prediction of the cancer data using the artificial neural network. That also has been done by my students only. So what they have done, I'll just show you that what method they have used. They have used some training algorithm, 5 or 6 training algorithms. All these training algorithms are definitely, I have not told you, and it is not possible also to tell all the training algorithms, but here I am giving you some the introduction of some algorithms. Let me just zoom it. Okay, so the first algorithm, it is saying the gradient descent algorithm that we have done already, and along with this there is another algorithm that is known as a conjugate gradient algorithm, right? So in conjugate gradient algorithm, only difference is that the calculations, or that how the gradient is calculated, only difference is like this, right? So initial gradient is your G0 and negative because it is a descent algorithm, steepest descent, because it is the part of that descent only. It has been development has been done in some gradient descent only, and it has been given the name as your conjugate gradient descent algorithm. So in conjugate algorithm, though it is not possible again to tell all the whole algorithm, but you can just see that important parameter is your beta k. In gradient or conjugate gradient descent algorithm, the different parameter is your beta k. With the help of this beta k, we have divided into various algorithm. For example, Fletcher-Reeves method, Fletcher and Reeves, they have given this beta k should be calculated like this, and it has been known as your conjugate gradient with Fletcher-Reeves updates, right? So this is your parameter with which the weights will be updated. Now another is your Pollack-Rivera method. So Pollack-Rivera method, they have given that beta k should be given like this. So if you give the beta k like this, then conjugate gradient will be, this updation will be in the different. So what they have done all these methods, that is Powell-BL method. They have written the program, MATLAB program for all these methods, and they have compared. They have done the comparative analysis. So all these methods they have done. Another after that, that is scaled conjugate gradient. These are all the parts of the conjugate gradient only, right? Fletcher-Reeves method, scaled conjugate gradient method, Pollack method. So all these methods are the conjugate gradient method. After that, they had done with the one-step second method. So this had been proposed by the BPUT, that is he has proposed this one-step descent second method. So what they have done, they have used the conjugate gradient only, but they have the gap between the conjugate gradient and the other algorithm. They have targeted to remove that gaps. So another algorithm is a Levenberg. This algorithm basically, in each and every neural network toolboxes, you have seen, I have told you NF tool, NPR tool and NC tool. In all these toolboxes, this Levenberg algorithm is used. Levenberg algorithm for training ke liye. So training LM, it is known as your train LM. When we train with the Levenberg, so the command is your train LM, right? So this is the command we use for the Levenberg algorithm, that is your train LM, right? So this is another algorithm for training, and after that again this is using the mathematical calculation, your Jacobian matrix and all. Then resilient backpropagation algorithm that we have already done. So these are the 5 or 6 methods we have done, and with this we have done all the simulations. Then we have done the comparative analysis of these methods. So they have taken only the cancer detection, cancer prediction. So similarly, same methods you can do for the earthquake prediction, same method you can do the humidity prediction, same methods you can do the pressure prediction, same methods you can do some other biological some terms, that prediction of something. So this type of work can be extended with this. So this is your simple 5 networks, or the 5 problems I have shown, 4 problems I have shown. And in MATLAB, I just want to tell you that here we had used the NC tool and NF tool. Similarly, you use the NC tool. Clustering, we have done the clustering tool. So for the clustering tool we use the NC tool, right? With the NC tool we can do the clustering, that means grouping. So let us see that what are the examples, same method we will do, that what are the examples are there for the clustering tool. We'll say next. Now it is telling that what are the inputs. You see for the clustering it will not give the targets, right? In case of the training methods we had in NF tool, we have got the NF tool, we have got the targets also and inputs also, right? Input and target both, because that was the supervisor method. But in case of clustering that I had done yesterday, that is your for ART, for the vector quantization and for the SOM, we don't require any target, because only input and the some precise value of the cluster, and we will check, and automatically the inputs will be in under which cluster that we will do. So that's why only the input values we want. So let us take the example data set. So it is telling that iris flower, that means the flower, whatever in which group it will be there. So for example we can see the iris flower. So here it is giving the inputs is what? Sepal length, sepal width, petal length and petal width. So these are the 4 inputs we will be giving in case of the clustering, and with this clustering we will use that in which cluster it is. So if we say import and finally that inputs will be there, we will say next, and here also we can give the self-organizing map and SOM that I have told you that what should be the 2-dimensional map. So this will be 10 cross 10. So this is 4 input and the output may be 100 or maybe something else. So after that we are giving the 10 cross 10 matrix. So whenever we will do this training matrix, that will be somewhat the point will be different. So whenever we will do the train, so it will be the training will be done of so many iterations. So it is coming. After that we can see here that is your plot SOM neighbor distances, plot SOM weight planes, plot SOM sample hits, plot SOM weight positions. Or after besides this we can get some here also same thing, SOM topology. So let us take the SOM topology. It is showing that SOM topology is like this. So this is the topology, means I have told you there are 2 topologies we use, right? One is your hexagonal and another is your square shape. Yesterday class I have told you that is there are 2 types of topologies are there. One is your hexagonal, another is your square shape. So this topology means this topology it is using the hexagonal topology, right? So this is all about. And after that SOM neighbor connections, so it will show you that how the neighbors are connected in the this hexagonal position. So this is your the neighbor connections. So SOM neighbor distances, now it will show you that how the neighboring, whatever in our case whatever inputs we have given, that is for the iris flower, what is the distance between the neighboring distances. Similarly you can get the weight planes. So it will show you the different weight planes, weight from input 1, weights from input 2, weights from input 3, weights from input 4. There are 4 inputs: sepal length, sepal height, petal length and the petal width. So for the 4 inputs, what will be the weights, right? For the 4 inputs, what will be the weight updation, and then is your sample hits. So it will ask you that how the sample has been hit. Matlab actually the how the processes or the steps are going on for first one. After that it will be remaining on the first cluster. After that it has gone to the second cluster. After that it has gone to the again first cluster. Then again the third cluster. Then again the second cluster. Like this, what is the process? So it is showing that these are the clusters it has been designated 1, 2, 3 and 4. So there are 4 clusters it has been shown. After that the weight positions, it is showing the weight positions, that how the weights are positioned in the plane. So different types, different weights and how they are the positioning. There are 4 inputs for the 4 colors they have put: green, yellow, green, red and blue, and other things is your orange. So these are the 4 for the 4 inputs that the 4 colors had been chosen. So these are some if you go in details you will come to know more and more. And similarly if you do the next and similar train again you have to give, and then again it will be trained, retrain it can be done, and after the retraining again the some topology or not topology, some weight planes and all these things that may be, you know, the values may be different. And this is your, when you will do the next, and you can generate the M file. So whatever we have done, so this will be generated in an M file, that you can see that is M file is generated here, and this up to this, that a plot sample and you know, plot heats, so that it is showing for the iris data set. So each and every problem, for each and every problem, I will suggest that you go for the GUI based method first. You understand that how the GUI can be done, and from this GUI the M file will be generated. You work on those M files first. After that you take one journal paper or the research paper, then you see that what they have done, you try to implement that what they have done according to your concept, and after that you try to modify, or some conclusions what they have given in the conclusion or the future work, you try to modify that. This way your thesis work, students thesis work will can be completed. So these I have just given you just an introduction, because it is not possible to, you know, go in depth that what is the research problem and what is the, you know, what we have done in our research problem. I have given you just an essence of the neural network toolbox, and how the programming can be done, and how the command we write for the basic neural network programming. So this is all about of this session.